All right, some of you guys missed the back to school night, and this is something I wanted to say to all of you guys, and what I wanted to say to your parents. So I'm going to go through some of the things I've been learning about in school. I'm going back to school because teaching is about not only knowing your material, it's also about constant learning. We want to, as teachers, become better. So I was reading this book. It's called How We Learn. And what I discovered about when I was reading that book was that many of the things that I do about teaching you guys how to learn things are the things I was already doing in class. But now I got context to the things that I was kind of intuitively knew were things that you should be doing in order to be successful in math. Here's the first thing I want to read to you guys. Turn over to the next page right there. It says this right here, goes, spacing out learning objectives. Do you see that? Mom's corollary. Honey, don't you think it'd be better to study a little bit tonight, a little bit tomorrow, rather than trying to learn everything at once? That's absolutely true. Now, you guys are on a block schedule, and this is the problem that I've always kind of noticed in block scheduling, is that I don't see you guys every day. And in order to be successful in math, you guys need to do math every day. If you guys are waiting to the last moment, it's 11 o'clock at night and today's Wednesday and I saw Kamada on Monday, and now it's Tuesday night and it's 11 o'clock at night, and you guys sit down and you decide you're going to do your homework. You've already missed about a 32-hour period where you haven't looked at any of your math, and now you're going to decide to do it. You're cramming. You're trying to cram that information into your brains. Cramming does not work. You need to take your objectives and the things that you're doing and apply them daily. Spaced out learning helps your brain to percolate the ideas. If you guys sat there at 11 o'clock at night and started doing it, you're kind of under a stress. You're stressed out about what's going on. You're not giving yourself time to relax and think about it. Because this is what happens in the cues in the environment. You start sort of like, oh, I don't really know how to do that problem, I couldn't really get it. But once you guys are sitting down or are percolating through the day and walking, things start coming back into your memory about how to do something. For instance, these things that we were just doing, composition, inverse functions, and domain and range, these are ideas that you guys have seen before. You've had them in other classes. You had them with Mr. Kruger or whatever Math 3 class you were in. I know he talked to you about them. But when you came in here, it should be like, oh, do I expect that you guys knew all of that stuff? I didn't. But if I start bringing it back to you guys and you start working on it, you can sit there and go, oh, Sally had a conversation with Alice about the dance. And we're going to go to a dance. Oh, and wasn't Mr. Kruger talking about inverse functions that day? Your brain's kind of like doing these subconscious things where it's connecting to the environment, things that you've already done. You kind of remember a day or an instant that happened, and all of a sudden those things that are happening come together. That's what it is about spaced out learning. The more that you guys start doing something immediately and letting your brain just kind of go through it, the better it's going to be, and you're starting to start making connections to all of this stuff that you've been learning. Here's the other thing that I think that you guys have probably noticed about this class compared to other classes, about me that's different. You guys are used to things that are just, when I would do things that were, for instance, this worksheet right here that you guys just got, it's repetitive. You do this, I do this, I do this, I do this. And don't you feel really successful about doing repetition? I know how to do this, I know how to do this, but it's not that repetition isn't bad, but here's a difference in my style. I mix up my learning. I gave you guys 4 or 5 concepts at once. I said, do this, do this, do this. You've also noticed that the way I do stuff isn't in the book isn't like linear. I didn't go page 1, page 2, page 3. I took all of these concepts because I know that these things go together, and I'm trying to, and it's called mixed up learning, and there's a difference between that and this repetition thing. Here, you're not seeing context to why you're doing it, you're just factoring. You feel really successful, I can factor. You guys did 20 problems on factoring, you come in and take a quiz and you just factored. But on my test, my last test, I gave you guys like about 7 things to think about all at once. You guys need to be patient with this idea, the way that this develops. Because it's not that I'm just going to go on with stop there and wait there. I'm going to come back and loop to these ideas over and over through the entire year. This f of x equals 0, this f of 0, all of these ideas you will see over and over. I actually kind of did this with your guys' thing. I front-loaded you with a bunch of theory. Now I'm coming back and giving you guys the Algebra 1 concept that goes with it. And now you're going to start making connections with what you learned in Algebra 1 with the pre-calc. And it's going to start becoming more clear to you if you have that patience to wait. So just hang in there, guys, on that stuff. Here's the other thing I need you guys to be able to do. I need you guys to be teachers. I need you guys to pretend that you are the teachers like you're in a play. Okay? You're in a play, and you get up in the morning, and what do? You rehearse your lines, right? You rehearse your lines. I want you guys to rehearse your math lines. F of x is equal to the square root of 16 minus x squared. You go into the mirror and you say something like this. That's a semicircle. It has a radius of 4. The domain of this semicircle is from -4 to 4. The range of this semicircle is from 0 to 4. Talk to yourself out loud like you're rehearsing plays. The other really big thing that you guys need to do and be able to do is talk to each other. Communicate what you know. So, like you rehearsed it there, you come into class, and now you're the teacher. I want you guys to pretend you're the expert on what's going on here. So that I'm going to say, you know how to be an actor? You know how to hack this too. A change of environment. You guys may have thought that this is kind of weird, but this is what I did for you guys, is that we were in here for a few days. We went down to the library. That wasn't me just going doing something random. Actually, when you guys change your environmental conditions, it helps you guys start making connections with the things that you're doing. It's kind of strange, but that's kind of the evidence out there in experimental science. So, for instance, you guys are at home and you guys are in your little room right there, and you're going and you're studying, you're doing all that kind of stuff. Take a break from that room, go to another room. Better yet, take a break from that room, get with some friends, go down to Starbucks, get together and start collaborating and start talking about your math. And being able to be the expert, the teacher, and start communicating what you do and do not know about the subject that you're learning. Guess what you also get to do, guys? It's called take a break. That's okay. If you guys want to get on social media, say, I'm doing these math problems and I'm just like, I'm tired, go ahead. Take a break. Go to social media, go do something else, whatever you want to do. Take a 5-10 minute break, take a half-hour break, take an hour break. Come back to it. Let your brain just sit there and kind of go percolate. Just going to start thinking about those ideas that you've been thinking about. Maybe you got stuck on something. Go to bed. Go to sleep. You'll dream about it. Has anybody dreamed about math problems? It happens. Your brain and your subconscious are working with all of these things. That's why if you have these changes in the environment, you're making connections out there with the environment in unconscious ways. It's really happening and you don't even know. It's like you're sitting next to Vazul. Vazul's thinking about something, he says something, all of a sudden, boom. Like something happens, man, you don't even know. It just creates the... Here's the other thing you guys get to do. You can listen to whatever music you want when you're studying. If you want to like just listen to rock and roll or whatever, have your earplugs on, and while you're doing math, you get to do that. That's okay. I personally don't do that. I need to be in a quiet atmosphere. I need to think and be silent when I'm thinking about math problems. I have to get into my own little space and just have it absolutely quiet. I'll have students come and go, come on, what about this, what about this? And I'm like, wait just a second, man, let me go to my desk and let me get into my dome here. And I start thinking about what I need to do, and all of a sudden it's just like, I don't even know where it comes from. Boom, there it is. It comes from some place. I can't explain it, but there it is. And that's what math really is, guys. You're stuck on a problem, you're working it, you're getting frustrated, take a break, go for a walk, go walk the dog, go kiss the dog. It doesn't really, do something, but you just kind of walk, all of a sudden you just like, here it comes, somewhere out of the blue. That's problem solving, that kind of thing. So we talked about changing your venue, that kind of things. I think the other thing is that we talked about in this class, and it started at the beginning of the year, was these things where we started off here, guys, with grit and perseverance, responsibility. I'm telling you guys, these are the things to do in order to be successful in this class. There's the moral, the ethical, the performance types of things that you need to take responsibility for. I told you to do math every day, do it every day. Here's the thing that I want you guys to be able to do tonight. This thing about self-test. Test yourself daily. I told you to find 3 problems from from your homework, 1 problem that you couldn't do, and get up the next day and do them again like you've never done it. When Michaela was here and you guys missed her, that's what she does in college. She doesn't just do 3 or 4. You know how much Michaela does? She does 65. 65 calculus problems every day, retraining herself on stuff. Let's try a little experiment right now. You guys are going to try to think about what these are really quick. How can you turn off that light for a second? Thanks, little light. I'm going to give them to you real fast. Okay, what is it? And here's something else. I want you guys to think about groupings of these objects. There's some of these objects belong together, and some of these objects don't. Ready? What is it? There was a collection of objects here. Some of these objects are going together. They're things that we've been talking about. Can you guys identify for me the things that weren't? Was that? We've been doing that?
Yeah.
How about that?
No.
I'm going to tell you guys, you are doing this. That right there, you guys know is the?
Quadratic formula.
That's the quadratic formula. What does the quadratic formula do?
Finds your x-intercepts.
It finds where your parabola crosses the x-axis. You're finding your zeros. That's f of x equals 0. Did you know that the quadratic formula was for that? Probably not, because your teacher gave you the quadratic formula, and you guys did that about 20 times, and you said, okay, I can do the quadratic formula. But did you have the conception of what it was about? It was about finding zeros. How about the factoring? Did you know that when you were factoring, you were finding zeros? What's that one? Pythagorean theorem? Does it belong in this grouping? Not really, does it? That's not what we've been doing. How about this one? I'm going to say you guys don't know that one. But you know what? It's something you're going to learn how to do. It's called synthetic division. And right here, if you saw f of k equals 0, you're finding the zeros of something like strange with third degree polynomial. That right there is for finding where it crosses the x-axis. How about that? Do you know what that is? I don't think so, but maybe you guys had, this is the normal bell curve. That's not what we're doing though. This isn't a part of that collection of things that we're doing. Is that a part of the collection of what we're doing?
Oh, yes.
Oh yeah, what is that?
Parabola.
Yeah.
What is it?
No.
It's that thing.
What? It's the snake thing, we call it the cubic. What's that one?
Linear equation.
It's a linear equation. So right here, you guys, this is another cool thing to do. Is take a bunch of flashcards, put them together, and start seeing how fast you can do stuff. Don't try to even think about what it is. Just start getting familiar with its form and all that kind of stuff, and your brain's going to start doing the rest. It's going to start making connections. It's going to start perceiving before you guys even know what it is, and that's okay. Just start getting into the rhythm of doing this stuff, and all of a sudden, math just starts flowing out like a play. Just like I'm up, it's time to act, and I'm not even thinking about my lines. I'm just doing. That's the thing that Michaela was talking about when she came in and talked this morning. Was she had friends that took calculus in high school. When they went and took the test to see what level you guys could get into, if you guys could get into calculus, she'd only taken pre-calc with me. Even the kids that she was friends with in UC Davis, they took the entrance exam. They wouldn't let them into calculus. Michaela was able, from my class, to be put right into calculus. She's been getting A's all the way through. So I want you guys to have patience about what this process is about. Hang in there, start doing the things I'm saying, and you will be successful. Okay?